This video is all about scatter plots. The main objective of this video is to have a bivariate data and get a graph which is called a scatter plot, and also to interpret the scatter plot. The scatter plot is used to display quantitative bivariate data. We know that when we collect a data, it can be divided into two categories, one as categorical and the other one as quantitative. The scatter plot is used to display only the quantitative data. We get a linear model, and the scatter plot is simply a graph of the points of a linear model, like y is equal to mx plus b or mx plus c. So we have got two unknowns, x and y. The x variable is the independent variable or the explanatory variable, and it is plotted on the x-axis. The y variable is the dependent variable or the response variable, and it is plotted on the y-axis. To understand this clearly, let us see this example. This example is all about the ice cream sales under a certain temperature. This is recorded by a shopkeeper. So we are trying to predict the ice cream sales using the temperature. So the temperature will be our explanatory variable or the independent variable, and the ice cream sales depends on the temperature, so it is a dependent variable or y or the response variable. So x is temperature, y is the ice cream sales. So by taking x as temperature and y as the ice cream sales, we can get the diagram. We can plot all those points in the xy plane by taking x-axis to be the temperature and y-axis to be the sales, which is our response variable. We get these points scattered all over in this diagram. So this diagram is called a scatter plot. Now, how are we going to interpret these scatter plots? After plotting the two variables on a scatter plot, we can describe the overall pattern or the relationship of the two variables. In that, we can look for the form of the pattern, the form of the points or the graph. We can say that whether it is linear, it is described as a curve, or it is all clustered or like a cloud, or there is no pattern at all. We can also see the direction of it. When I say direction, it all depends on the slope, whether it has a positive slope or a negative slope. If it has a positive slope, it'll have positive direction. If it has a negative slope, it'll have a negative direction. We can also talk about the strength. That is, we can see how closely these points are connected. That is connected to a line of it. And also we can check whether there is an outlier for this data. That is, if there is an outlier, then there is no strong relationship. When we talk about the relationship, in the first diagram, it looks like as x increases, y increases. So it is linear and it is in the positive direction. So we say it is almost a line, and we say that it has a linear relationship. Whereas in the second diagram, the points are scattered all over. It doesn't lie on a line, or it's not close to any line. So we say that it has a weak relationship, or there is no relationship at all. The third diagram, though I don't have a line representing all this data, I can still imagine a curve. So it is curvilinear, or we can say that it is non-linear relationship. The first diagram, as x increases, y also increases. So it has a positive slope, or we can say that it is positively associated. The second diagram, as x increases, y decreases. So it has a negative slope, or it is negatively associated. In the first diagram, it looks like the points are almost lying on a line with the negative slope. So it has a strong negative relationship. Whereas in the second case, though I can imagine a line with a negative slope, but still not all the points are lying on that particular line. So it has a weak negative relationship. Now in this diagram, I can imagine a line representing all this data. So this point may not be an outlier, whereas the point here will be an outlier. So by seeing the diagram, we can check the form, the strength, the direction, and the outlier of the data. When we have the scatter plot, we can try to represent a line. That is, we are trying to fit a line which will represent all this data. And this line is the line of best fit. So it is also called a linear regression or regression line. The technique produces a line that is the best fit for a given data. Although you can find a linear regression line by hand, you can fit this line by hand, we prefer to leave the calculation to a graphing calculator or a computer. For better accuracy, we can calculate the line using least square regression and the least square calculator. So in this case, in this diagram, it looks like the points are very close to the line. So this line is the line of best fit. And also it has a strong relationship because the points are almost on the line and they're close to the line. So it is a line of best fit. We can use the line of best fit to find the values which are in between the given set of data or outside the set of data. So suppose if I'm trying to find a value inside a set of data points, that method is called interpolation. For example, in this case, though the value at 21 degrees is unknown to us, it is not given in our set of data, we can still find the value corresponding to 21 degree by dropping lines like this. So when I drop a vertical line through the point 21 degree, it looks like the approximate sale will be $480. So we can predict a value for the temperature which is inside our set of data point, and hence this method is the interpolation method. We can also find the value which lies outside the data. That is, if I'm trying to find the value for 29 degrees, since the values were given only from 10 to 26, if we are interested in finding for 29 degree, which is the value outside a set of data point, we can still get that result as 740, and that is our extrapolation. So the line of best fit, or the regression line, the linear regression line, is very helpful in finding values which are inside and outside our set of data points. That is, for interpolation and extrapolation, the line of best fit will be very helpful. So in this video, we talked about the scatter plot. We interpreted the scatter plot, and also we fitted the linear regression line, or the line of best fit, to find the interpolation and extrapolation for a data. Hope this video was helpful. Thank you for listening, and thank you for watching this video.